Okay, so 06 Ford Explorer 4.0 overheating problems. Changed out thermostat housing, coolant sensor. Um, Seemed to be staying a tad bit cooler. Thought everything was fine. Customer came back with it saying that it was overheating as he's running his AC at idle. Or driving it with no air conditioning, it doesn't overheat. Only when you have the air conditioner on, and thus it needs a higher fan speed. I noticed it's got a pretty much a brand spanking new electric fan clutch, and I noticed on the harness, the vehicle harness, that there was repaired under the wiring. I just got done repairing it myself. The previous repairs were taped. Each wire was taped individually. But they weren't, after that, taped all together, snug together, so that would prevent the electrical tape, after it heats up, from sliding off of it. Because I noticed that all the tape was already kind of melting off, and it was sliding off, exposing the copper wires on one end, and it looked like they were touching. So after I saw that, I started suspecting that maybe something touched and shorted out one of the electric fan clutch circuits. So I'm going to show you something real quickly. Okay, so let me go to I'll do the original test first. So put those down. There's that. Just put this down for 2 seconds. Okay, so we're gonna zero it out because we're gonna check resistance, ohms. Okay. So I got a diagram right here. Electric fan clutch and the different circuits that are on there. So fan clutch variable circuit, okay, to the PCM, it's white and blue wire. On the harness that, if it was original, it'd be blue and black, but this is an aftermarket one, so it's not that. So I have to look at what wire the original car harness connects to. So anyway, if you look on the car harness, you'll see a white wire with a blue stripe. White wire with a blue stripe. That's fan clutch variable, okay? And basically I wrote down real quickly 2 tests. It passed the first one, but it failed the second one. Pin 3 and pin 2, check for resistance, and what I should find is between 6 and 12 ohms. First time I measured it, I found 8 ohms. That's within specs. But I'll show you what wire that is. 3 and 2. So pin 3 is the fan clutch wire, fan clutch variable, and 2, which is vehicle power. So between this circuit and this circuit, I should get these ohms. So I'll show you real quickly what those are. That is going to be, it's going to be 1, 2, 3, that one, 1, 2, that one. So the 2 on the end, those 3 right here, they're not used. So what I'll do is I'll place one wire right there. Hold that up for a moment. That's fine, as long as it doesn't fall out. Okay, that's fine for now. And the other one. Wait. Kind of hard to do this while holding the phone. Okay, those 2 wires. So I got the wires in the right pins. Now what I should read is somewhere between 6 and 12 ohms once I connect these wires together. So now that it's disconnected, it'll read nothing. Connect the first wire, gonna connect the last one. As soon as I connect the last one, about 8 ohms. So that's within specs. So boom, that's good. Now I have to check between PID 3 and ground. So if you look here, PID 3 is still fan clutch variable, and ground is going to be number 4. Number 4 is going to be the black and yellow wire. So if you look on this connector, you'll see the white with the blue stripe, that's fan clutch variable, and right next to it is a black with a yellow stripe. That's the negative ground. So that means that it's going to be those 2 pins on the right hand side at the bottom. 1, 2. Those are the 2 I got to double check on the same side. So this one, the yellow lead, is exactly where it should be. So I got to take this guy out, and I have to put it into here. And basically, when I do this, I should be reading more than 10 ohms. And I have my multimeter, my paragraph meter, set to automatic mode, so when it detects a certain type of resistance, it'll automatically jump to that scale. So it's reading mega ohms, alright? And it's still open, it's still out of range. That circuit is bad. Okay, and just to give you the benefit of the doubt, just in case maybe it's reading such a high resistance that this doesn't pick it up, I should be able to check for continuity. And to do that, I exit out and go down and do check continuity. Here, and I'll show you exactly what that does. Let me disconnect this, let me disconnect this, right, and reconnect these guys together. Gotta reconnect those, put that up there. So that's closing the circuit. Now let's go calibrate. If you hear that noise, that's indicating that it's a closed circuit. The moment they come off from one another, it doesn't make that sound anymore. So if I connect this right here and this right here, it should make a sound. It feels there's continuity. No continuity. Let's see that harness. Harness is right there. I'm not making any continuity. Now, well, let's go check that first circuit. The first circuit that I already know that did pass its test. So no continuity, no sound there. So I'll take this out. Just kind of push that up so it's in the camera's view. And I will put that. Hear that sound? See, there's continuity there. That means it's a closed circuit. It's good. Don't touch the tin. See, open, defective. So in essence, basically, the exposed copper wire, when they touch, they shorted out the electric fan clutch. So even though this is a brand new aftermarket one, it's already defective. And that's the problem.